Okay, folks, so let's start. So as we discussed in the last class, we have started learning about network security. Okay, when we say network is computer networks, which you have been studying, is when we in fact mean a network, computer networks is today is just internet. Okay, all other aspects of networks have almost vanished or vanishing. All right, so today we'll look at physical layer security and we'll also understand what data link layer is, because next two lectures will be on data link layer security. Contents I have taken from many sources, you can go through it. Okay, so the first thing that we'll cover is security in layered architecture, physical layer security, device security, common stealing methods, and some tools, and then link layer introduction. Now this diagram you would have seen hundreds of times. Okay, I mean to say is that this 7-layer OSI architecture, right? And as we discussed in last class, we use only these layers: first layer, physical layer, data link layer, then network layer, transport layer, and then on top of that is application. So this we don't have in internet. Is basically the functionality of session and presentation layers are clubbed either in application or you know or really not needed. Okay, session is like TCP session here, right? I mean, we create a session and then or dialogues, and when it's over, right? So for example, UDP doesn't require session, right? But TCP is session oriented protocol. All right, so this, when we have this architecture of internet, these layers, okay, what is the security that is needed, and how does security of one layer impact security of other layer? Now note that these layers are kind of independent in the functionality is independent. That's a layering concept, so that you make changes in one layer doesn't impact other layer, but they are also dependent on each other. There's interdependency between them, right? Because data link layer works over physical layer. Okay, network layer runs over data link layer, and transport layer runs over network layer, and so on. Ultimately, aim is that there should not be any problem to application. But if there is a problem of any of these layers, then there is a problem, of course, on application, right? All right. Okay, and application cannot take care of everything, whatever malfunction is happening here, and security issues are here. Okay, so we have to look into security of each of these layers. All right, and also look at how can we secure applications. So let's start. Okay, so security in layered is it really a problem? Of course, yes, we have just discussed this. What happens if one layer is hacked? Other layers aware of this? So there's a great advantage of having this kind of architecture, layered architecture. But there are problems also, because they are independent functioning. Function of this independent. It means that functionality that you create here, of course, depends on something that comes from below, but this functionality of this independent. So if something, let's assume that if there is a hack in network layer, okay, there's some security issues there, would transport layer come to know about it? Can anybody answer this? If there's a problem in data link layer, would network layer come to know about it and take corrective action? No, it cannot, because functionality is isolated. Okay, so it means that if lower layers are compromised, any lower layer is compromised, then higher layer is compromised too. Okay, it means that impact will be there in all layers above it. Okay, and we know that security is as strong as the weakest link. and weakest links are layer 1 and layer 2. Now you must be wondering, layer 1 is just a piece of wire, and the way signal travels from, it's a wire, or maybe it's just air. So what kind of security thing can be there, right? But there are. So that's exactly, we look at some of the aspects which most of the companies do implement, right? Okay, so this diagram shows that there's a domino effect. If something compromises there at lower level, all layers are compromised. That we need to remember. So it means that we cannot really just improve security of application layer and everything will be improved. So all these layers are to be secured for providing security to higher layers. So let's look at the first physical layer security. What will happen if you have fiber optical cables running in the city, and monkeys love cables, for some reason or other. Okay, and then monkey cuts the cable. Can application layer take care of it?
No, sir.
Of course no, right? And these kind of things keep happening, that, and one fiber can carry thousands of terabytes of data. In fact, one fiber strand is good enough to take all the communication happening in Bangalore to outside world. Okay, there's a capacity. So if fiber, this is not single fiber, it may have, say, hundreds of fibers inside. And monkey, of course, is a very interesting character and loves certain things, right? And then cuts the cable, then it's gone. Whatever protocol you run inside will not work. Okay, all right. So the question is that to defend physical layer, what all we can do? And that totally depends on budget, situation, and the purpose. Why? How? See, in Bangalore and many other cities, you will find this fiber optical cable going to IT park and so on, just hangs through, trees. I mean, it's all in open, because, the municipal corporation or government agencies or private agency have not thought of creating a pathway only for cables. Okay, so totally depends. Now this problem may not exist in let's say California, but there are other problems out there. Okay, their municipal corporation may not allow even laying of new cables. So good part of USA, internet speed is lower than what you find in Bangalore, because Ethernet cables are not allowed, so they are still using telephone cables. Okay, just somebody needs to mute. Okay, just mute on. All right. Okay, so I mean, totally depends on how much money you have and what kind of situation you are in and what do you want to achieve out of that. So physical security in general, or physical layer, which will say physical security here, depends on intruders, vendors, and thieves. It focuses on them. And this is the oldest aspect of security, which we have been doing for ages, right? Okay. And another thing, see, the corporates have large number of employees. Okay, and not all employees are honest. All kinds of employees, all kind of people exist in universe, on earth. And so any organization with large size may not want any thief inside, but there are. Okay, and corporations like IBM, for example, is one of the large organizations. I mean, they may have what kind of number of employees IBM will have approximately? Any idea? Or even bigger organization than that. There are many bigger organizations. Maybe TCS is bigger in terms of numbers. Number of employees is something, as big as few lakhs, maybe 4 lakhs or something like that. TCS may also have. Now, 4 lakh plus employees. Must be, I don't know exactly, but you can always find it out after Google. So when you have 4 lakh employees, don't you think that there will be people who are criminal minded, who are thieves, who are naughty guys? I mean, who just want to create trouble. There are people who may want to monetize. There may be employees who may want to steal IP information, intellectual property information. There are people who are interested in not IP information, maybe stealing physical assets. There are people who may want to just inject some data and try doing something. Okay, there are people who may want to copy the whole source code into flash drive and then take it home. Okay, there are people who may plant a logical bomb. Logical bomb we'll study later. See, it's like this, that I am leaving company on 31st of say March, and this company has troubled me. I am not happy with it. My manager is not good, and all those scripts I may have, and say that create a software, a small program, on it's a 2nd of April or 3rd of April or some date. This guy decides it will encrypt the whole company's data, or it can wipe out the whole company's data, and company really has trouble because of that, right? Okay, or creates checks in part of the software uh, into the main code that will start giving bugs after a certain time. Okay, and this is very common thing that can happen, that employees, when they exist, they try, their love affair with the company is over, and they start hating, and some of them may want to harm the company. Okay, all right. So, and this is called insider threat or insider attacks, and these are and most of the attacks that happen in company are by people who are inside. Okay, and all kinds of things they can do. I mean, they can connect their laptop to unused port in a router. They can want to steal data, design code, etc. This is very common. Actually, I have asked in the company I was heading that when in one of the session, that company depends on only on the code it has developed, okay, and selling the code. Now when you go, what is it, you have developed some code, would you like to take it with you? Many of them said, yes, it's my property, I have done it, why can't I take it? Then I asked him, why company is paying you money, and everyone, if you take everything, then how company will take a money? So make a money in future, because you will sell. So intellectual property of the company, whether you developed it or not, whether you patented something, that's company's property. Please remember that. Never try to take anything out of the company wherever you work, because it's a inside, it's a stealing, is a fraud, uh, it's still a criminal activity. Okay. Now look at this diagram. This just gives details of insider threat. Okay, and you can get the details, right? It could be a company is not just only software engineers or developers, right? It has all kinds of people, right? I mean, there are people who are currently working, there are people who are formerly working but still associated with company, there are full-time employees, part-time employees, temporary employees, contractors, and business partners, and many, and depending on what level they are and what is their role, access are allowed. So enough threats can be created by any one of these. Okay, and any organization has assets like information technology, facilities, even people are the biggest asset, right? And as simple as that, you can a person who is in a company, okay, passes on all colleagues information to competing company, that itself is a fraud. Okay, all right. And then this fraud can be done intentionally or unintentionally, like typical fraud, intellectual property stealing, then cyber sabotages, workplace violence, social engineering, whatever, all these, right? all right, and it impacts the organization is very, very big way in millions of dollars, all right. So insider threat seems to be so insider threats, it appears to is not really important, but actually people realize, and there is statistical data that most of the harm is done by people who are inside. Okay, now outside world you can protect an environment. This outside world you can have all kinds of things to protect, right? But people inside have access to everything, most of the things, right? Okay, that is the reason we have one principle we have studied, right? That is, if there is a developer should have access to only code that he or she will work on or is necessary. Okay, all other things may be available to him or her as a executable. Okay, only if it's required. Okay, and if your role is that of a marketing guy, sales guy, or CEO or vice president, you're not allowed to see the code. HR functions and admin functions are not allowed to see and manipulate the code, right? So you are given only access rights or information that you are really it's necessary for you to know. All right. So when you go to office, only if you are your own office where you are employed, only you are allowed to go inside only if you are employee. But it's not written on your face that you're employee until there is some sensor which can do some fingerprint scan or iris scan and so on, right? But there is, of course, there are every, whether it says fully automatic, there are gates, there are guards, there are ground designs. Okay, it's and there are access control. Only if you're allowed, you will allowed to go inside the office, and within office there are multiple levels of access control that you may not be allowed to go into, right? I mean, you may not want, you are not allowed to get into, for example, server area. Most of the employees are not allowed. So here, this principle that we discussed just now is principle of least privileges apply in organization, that a marketing guy is not supposed to know the code. Okay, and then of course employment checks is very important. I mean, the employment checks, nowadays HR goes to Facebook and so on and tries to find out the character of person, and then try to find out if there's a police case against the person, and all kinds of things happen. So no company wants thieves inside, right? Okay, and there is of course device security. Okay, basically within the organization, one has to secure computers, network, routers, switches, servers, laptop, etc. For example, in many organizations which is open office design, okay, laptops are there on desk, but laptops are locked through a chain. Okay, so this chain is given, and the special kind of laptops come where there is a lock can be applied, so nobody can steal it, right? A company where I worked, they gave me a special screen which will have to put on the screen of the laptop so that somebody cannot do shoulder surfing, which will study just now after a few slides, right? The another important control that we have is called session control. Basically, I mean, you get into a bank's website, you're not allowed more than few minutes. You have to finish it within few minutes, right? Otherwise you have to re-log in. Okay, there's one way of providing security. Or for example, there's inactivity of some period, then we log it off, right? So this is one simple kind of security. Similarly, every company should have policy to secure data. For example, employees should not be allowed to copy any data which is company confidential on USB drive. Like, I mean, you may come to know through directory employees and the details, you can just copy it on flash drive and sell it in the market. and a lot of headhunters will buy it happily. Okay. Employees, most of the companies don't have DVD and CD writer on the laptops nowadays. They also, most of the organizations don't allow USB drive, because there's no need for anybody to use USB. Okay, so USB drives are disabled, and then there are a lot of tools where whatever you are doing is monitored. Actually, each of your keystroke can be monitored with these tools. Okay, and all the emails that goes out are monitored through, there are some tools like Barracuda we have purchased. There's one company called that creates Barracuda. I'm forgetting the name of the company. Okay, so these tools can be used to monitor what employees are doing. There are hidden secret cameras in the company, and then they monitor physical monitoring of the employees also happen, right? But your digital activity is monitored in all organizations. Okay, so that if USB drive is disabled and a still person wants to steal, then employee can send it over email. Okay, so emails, if it goes through email, then emails have to be monitored. All right, many companies don't allow access to, of course, entire code and design documents. And then, for example, many companies, even India, never allowed employees to take out the laptops to home. Of course, I mean, during pandemic time, all rules changed, but before that, even at the level of vice presidents, people were not allowed to take the laptops out, because it's the simplest possible security threat. Okay, all right. Many companies, of course, encrypt. Encryption is necessary. Hard disk, whatever you have in hard disk is encrypted, and then decryption key comes from server. So all that, these are the methods. Right? Common stealing methods. One of the methods that criminals can do is dumpster diving. Basically, I mean, for example, you have a code, you would have taken a printout of the code and you do debugging, using paper and pencil, and through that in a dustbin. Okay, and somebody can steal it from here. Okay, and I mean, these criminals look for credit card details, IDs, passport numbers, source code, etc. All right. Okay, shoulder surfing is another method. That the person is doing something very confidential and somebody will come and say hello and try to see what's happening. It's very, very common. This is an example of intimate partner threats that can happen. I would request you to go through what is intimate partner threat. Okay, it's like a couple, the intimate partner, right? Spouse, husband, wife, and one spouse is taking all the money the other spouse is earning, and then controlling complete life, then giving small amount on daily expenses, right? Because the one spouse has shared all banking, bank login ID, password, etc., etc. And this guy also knows, wants to see what's happening on her Facebook page, wants to steal user ID, password, and then keep saying what is she communicating with other friends, and so on and so forth, right? He or she, sorry, I'm not saying, it could be either partner. Okay, so these are very, very serious threats. Okay, it happens when there is a break in relationship, and then other partner has all the information, digital information, right? Credentials, and then all these kind of things keep happening. Okay, and it's very, very difficult to handle this. I mean, it's kind of insider threat. Person so close to you is cheating on you. Okay, so please, because you are a kid, and then please take care of certain privacy of yours and don't invade into privacy of others, and don't steal information even from your intimate partner, because everyone has a private life and something that one wants to keep confidential. Okay, any question up to this point? No? Okay, let's move ahead. If you want to disrupt all the communication in office, your office, if you in Bangalore, you don't need to do anything sophisticated. Just buy a cable cutting scissor, and you will surely find cable hanging out, because there is no formal way of playing cables still in this country. Okay, and then criminals can steal full data from these cables. You just cut the cable and put a connector, and then take the data out and let the data also go in. Okay, you can a kind of repeater you can have here. Okay, and this is the example that you'll see in big cities in our country. Okay, so, and there are hundreds of tools available for stealing. For example, TCP dump. I think you would have studied this in your networking course. If not, please read it. Okay, you can get all kind of traces using this tool. The another thing that you would have studied, I'm sure there would have been assignment on this, is called Wireshark. Okay, it's basically protocol analyzer, which you can use to analyze protocol data in very meaningful way, right? So you can see what's happening on network at very low level. Okay, you can do deep inspection of protocol. When you say deep inspection, what does it mean by deep inspection? See, outer way inspection is that there's a packet and you can see how many packets are being sent and so on and so forth. When you say deep inspection, you go into data part of frame or IP. If it's IP packet, then look at the data part. IP packet, look at the data part and see what's happening, what kind of data is being sent, and then copy it, right? Okay. So a lot of things can be done with Wireshark, and please go to the Wireshark website and read it. Okay, for example, this is one Ethernet tap. You can have this is switch, and then you can put a tap here. Okay, and this is commercially available, and one output of that goes here, so everybody thinks it's a normal connection, but you take the connection out because you just replicate the signal or take the signal out and then run Wireshark and find out what exactly is happening. Okay, another tool is you can steal it from fiber without cutting it. Here you are putting a device in between, right? So if there's a wire like this, you'll have to cut it and create a connection like this. Okay, but here in this case, this is a fiber cable. If there is a band in the fiber cable, the photons are leaked. More the band, higher the band, bigger is the leak. And these photons which go out of the cable can be collected, and then data can be read. There's a lot of tools available around this, so nobody will come to know. You just put your device here where there is a band, and then there is a sensor here or detector here, and which can send the data. Okay, so there are a lot of commercial tools are available. Read this, how in around 70s how data has been stolen from Russian networks. Okay, so physical layer security is real life threat. These are actually around real life threats. These threats don't require too much expertise in digital technology, and so on and so forth. These are the example. I mean, like some of these we have studied: wire tapping, stealing photons, network tapping, shoulder surfing, dumpster diving, accessing free ports on server routers, injecting jamming signals, and so on and so forth, right? In organization, there are hundreds of ways the employees can disrupt the operation. I mean, one thing that an employee has done, he or she wanted to have a break, want to go away for a few hours. Somehow she emergency siren, she initiated that, it started all that, and it's a fire threat, fire alarm started ringing, and so on and so forth. And then whole organization has to, as a protocol, whole organization has to go to the ground, and then they will check if there is a real threat or not, and the whole process takes about more than 1.5 hours. By the time person has went out, did his work, and came back, and finally got caught, of course. But a lot of things people do. Okay, all right. So any question? So when you join organization, look at the things that organization provides for physical security. Okay, how things are protected in the organization, because every asset that we'll use is company's asset, and company needs to prevent misuse of that. Okay, a simple question. You have a printer at home, and then you have to print tickets, or something. Okay, you don't have paper, and a paper minimum number of paper sheets you will buy is usually 100 or 400, and you don't want to, and you don't have time also, right? In office you have papers available. Can you take out the paper from a printer, and then maybe 10 sheets can you take home? Is it legal or illegal? Is it a theft, and can you be fired for that? Any question? Any answer?
It's not legal, sir.
No, it's not legal. Okay, if you want to take something out, ask the manager, sir, I need 5 sheets of paper, can I take it? He'll say, yeah, take it, don't worry, I will take care of it, or I will inform admin guy. That's it. Okay, but don't take it up, right? I mean, in my company, one employee had this very strange habit. After evening snacks, whatever snacks are left out, he will pack and take home. I mean, one hand it's good, one hand, but he was caught doing this. I mean, 3-4 times. Then admin guy told him not to do that, because the habit is not right. On one hand, is of course is leftover and will go waste. Why not take it home and then give it to? But there is a way one has to do things, right? I mean, something is there doesn't mean it's your thing. All right. So just take care of it, because many of us not aware of some such small things which we need to take care of. Okay, now we come to link layer. Okay, this is second layer on top of physical layer. So we have physical layer, which is nothing but wires and so on. Then we encode signal and transmit. And top of that we have link layer. Okay, and then of course we have network layer. What is the role of a link layer? What is a link? And what is the responsibility of link layer? Just think. I mean, you have a network. A network consists of multiple. I mean, when you're sending a packet, you are sending it from here to, for example, there may be a, this is the endpoint. Okay. So what is a link here? This source is the destination, and you are sending a frame or packet. Okay, there's a difference between frame and packet is that when we are at layer 2, we talk of frames. When we go to IP layer, and higher, we say packets. But we will use this term interchangeably. Okay. So where is the link here? Anybody? Let's call it A, B, C, D, E, F. So this is source and this is destination. What is the link here? Who can tell me? Otherwise, I will ask. Divya, can you tell me?
It's not the path.
Path is not link, ma'am. Path consists of number of links. If when you're going in this way, this is the path. It consists of A, B, B, C, C.
Router,
Pardon?
router, or ABC. This is a link.
Yeah, this may be a router here. This may be a router here, right? So this is a link between these two routers. This is a link. It includes part of a router or switch or whatever, right? This is a link. This is another link. The third link. Okay, this could be you know, for example, your Ethernet. This you are sending over satellite. This could be your fiber. Okay, so this could be your Wi-Fi. I mean, this may be Wi-Fi. So link is between two points of, think of wire or one like in a graph. You have a link. Same thing. Same link we are using between two nodes. Something that connects is link. Okay, so this is a link between two on a path. We create multiple links. Okay, so for example, I am talking to you. I am using at least 5 or 6 links or even more than that. I don't know how many links I am using. Okay, when I am talking to any one of you, so I am I am right now using my laptop, and laptop is connected to my router, which is just within few feet, but I am using Wi-Fi. Okay, my router is connected to you know, a main router or switch in my complex building, which will get, you know, connections from many other residences. And then this on the back end, this is connected to you know, area wise router, and then it may be connected to other routers and so on, and reaches to your side, right? So this is a link. First link is this one, my Wi-Fi router to you know, the router, and this link is running a this is a Wi-Fi. This is basically air and using Wi-Fi. Second link is fiber that goes from my router up to buildings router, which is running a protocol, which is maybe another Ethernet or something. Okay, but this is another link, and from that router to city router, okay, this can be another link, which is again maybe fiber, and so on. And somewhere or other, if there is a fiber is not available, it can go over satellite. Okay, then that is a link. So a network consists of multiple links. For I will just jump over. See, like this is a link, a Wi-Fi, for example, and the path is this is Ethernet. This could be Sonnet, for example, is another technology, and this is fiber for it. Or this could be through satellite. Okay, so now my path here, this path consists of multiple of links. Now when we talk of link layer protocol, the responsibility of that protocol is only for that link. That's it. It is not concerned about the entire path. It's just, you know, is part of the path. I will give an example, and you know, always visualize it through analogy. If you have confusion, you are sending a letter. Okay, Okay, so you created a letter or put this in an envelope and so on, and write the name of and put this in a box or whatever, and write the name of sender. So I'm sending it, for example, in Bangalore to you in Delhi. Okay, I will write your name, address, and so on, that sender's address and receiver's address, and then I will write my name, etc., sender's address, and give it to my helper to take it to post office. Okay, my helper is a bicycle. Okay, now protocol is that this box will be delivered to post office and some money has to be paid. That person will go on a bicycle on road. Okay, and that along with that, the helper may take letter from my wife, etc., etc. You put in a bag and take it to post office, and post office will hand it over, and from there my box will be taken out. Okay, and postmaster. So my first part of journey of my letter, it's nothing but protocol is that giving and receiving, and it will go over road on bicycle. Second phase is that from post office to central GPO, it will go over a truck, okay, or van, and multiple such packets will put together. But again, it will be over link is then road, but it will go with truck. Okay, and from there GPO, it will next it will go to Delhi over flight. So it will get clubbed with other packets, and then it will go over flight. So now responsibility of link layer is that my letter from one end to other end reaches securely in an orderly manner. That's it. Once my helper takes it from my home to post office, that job is over. Then he can forget. Okay, whenever I give next letter, he will take the next letter. That's the role of link layer. And then the next link layer from post office to GPO is their responsibility that the letter goes or box goes from one end to another end. Okay, so here this is a responsibility to make sure the packet frame goes from one end to another, frame goes to again here router 1 to router 5 and so on. That's it. And once it goes, each link does its job, then on top my my letter reaches the destination, provided somebody tells where to go. Okay, here for example, there can be many paths in which my letter can go. It can go through this path also. Okay, this path also, right? This way. Who decides this? Now, who decides who's going to have path is nothing but next layer, which is the network layer. The network layer says that, okay, put your packet inside a bigger packet, and then it will go over this path. Okay, so path decision, because there can be multiple paths, is not the responsibility of link layer. Link layer will say that given one path to me. Okay, so if this guy decides that, okay, if this guy decides that this is the part of the path, then it's responsibility of link layer of that link to deliver it properly. This router decides that this is a path. Okay, somehow it decides using some BGP or OSPF or whatever, some intelligence. Then the responsibility of these entities that make sure your data or packet goes to other end properly. That's it. So this guys, this protocol here could be different from this protocol depending on type of link. Okay, so now let's come back. Okay, so now every node will have these three layers, right? Because we have seen that if this is a link, then it should know how to transmit, and then node has also decide where to send if there are multiple routes. Then every node has three layers: physical layer, link layer, and network layer. Now transport layer handles only end-to-end reliability, okay, like TCP, etc. Then it can run this source, and if this is a destination, it can run only at end-to-end. If packet is wrong, is not reached, or is some bits are missing, then it can request for retransmission. Okay, all right. So this we know now, that for each hop now we need this, like we have hop here. The link layer is responsible only for this link. Okay, while network layer is okay. All right, so here the context is that if this is Wi-Fi and this is fiber, the protocol here would be different, because it's it's responsible to send the packet over Wi-Fi, which is different from sending packet over fiber. The protocol here will be different. Okay, so these two layers will differ for each hop, while the decision of how packet will go, what route it will take, is the same. So network layer is the same for all nodes, while these two layers, link and physical layers, are different. Okay, all right. So this we have seen. So the link layer responsibly by now, so we'll skip this. Okay, and Ethernet is a de facto technology. Okay, and something that we use is media access control, MAC protocol we use. Media access control, because I mean the media is nothing but a wire, and then it's connected with many machines. So media is shared across many others. Right? So if it's a fiber, or sorry, cable, copper cable, then this is the oldest type of Ethernet, and then because it's shared medium, then there is some control mechanism who will use a wire for communication at a point in time, and there is a protocol for that which is called CS513. So I request you to please go read about CS513. Okay, so Ethernet is a de facto technology. I mean networking. So LAN, for example, had token ring, token bus, and many others, all gone. Okay, it survived. Ethernet survived. And it's becoming very, very important, very, very popular, and we have now terabit Ethernet. I mean, it started with very low speed, 100 Mbps, 1 Mbps, 100 Mbps, 1000 Mbps, and so on. So today we have Ethernet that work on terabit speeds. It's very, very fast. So, and since internet speeds are increasing, so Ethernet is able to match up with the speed. Okay. Now there are a lot of different kind of wiring speeds, wiring schemes, and data rates, and so on. But the format is the same. Frame format remains the same. Okay. So these are different kind of mediums. For example, Ethernet can work over unshielded twisted pair, shielded twisted pair, fiber, or wireless. Okay. And you can see evolution happened this way. So this was the initial one. I mean, me and Professor Gonzalez in IIT Madras. Professor Gonzalez, in fact, started actually putting these cables in early 90s, 88 or 89, and then this was a scheme, right? I mean, there's a big thick wire that went to the building, a department building, and then everyone will put a hole here and to connect their laptops, desktops. Laptops were not there then, right? So this was, and once you use CSMACD, carrier sent multiple access collision detection. Simple protocol is that when somebody transmits, all others will listen, all will receive, and receiver will accept. And when two people try to transmit together, there will be collision, and collision will be detected all, and then transmission will stop for some time. Then again, people can try. Okay. Next was is that we will why do all this? Let same wire pass through multiple desktops, and this also had a problem. If there is a problem in this machine, then things will break. And this is the latest one. We have replaced this by a hub or switch, and all machines are connected through this. So, but if you collapse this, then it's nothing but it's a single wire. So this is a basic concept. Okay. So now we have moved from this bus based method of Ethernet to a switch based method. Okay, you would have seen this. Okay, and now we are more than gigabit, 100 gigabits per second. Please go through this slide set which talks of different kinds of Ethernets. Nowadays we have a switch, or basically switches. Hubs are not used anymore. Sometimes you may still use hub, but basically we have now Ethernet switches, and we'll understand what's the difference between switch and hub. Okay, and this is a format of Ethernet. Okay, we have 48 bits of source address, 48 bits of destination address, then we have VLAN tag, and what type of protocol we are running on top of that, right? Whether we are running IP, most of the time we run, of course, IP, but we can run other protocols. So that's told here, because IP packet will sit inside Ethernet packet, right? So there's a header, and then here is IP packet. Okay, but it should know how to interpret this, what is syntax and semantics of what is inside. That one come to know only by this type field. So for Ethernet, we say some bits which will say that there is a IP inside. Okay, all right. So security in Ethernet is that we'll have to find out if Ethernet is really secure. Okay, can Eve read frame sent from Alice to Bob? Can Mallory insert her own frame from sender name to Alice? One can always, change the MAC address and keep putting frames inside. Can today bring Ethernet network down? Something, I mean, these switches are there in offices, and if today wants to bring whole network down, what can you do? Can we overflow the routing table inside, or which we look at CAM table? CAM stands for content address memory. Okay, I mean basically table inside, routing table inside is CAM type, so the searching time is less, and so can overflow happen? Can Mallory do DSCP attack? ARP poisoning can be done. Spanning tree attack can be done. So all these are the problems which we'll study in the next class. All right. Okay. Any question? It was really fast because I know most of you these topics have been covered in your networking course. Are you able to understand the difference between networking layer, network layer, IP layer, and data link layer? See, most of the students have no clue of this. They would have studied what each layer does, but visualize it. What exactly is happening? What is the responsibility of link? And how is it doing? What is the responsibility of IP? IP is not bothered about link layer. It's just for interconnection of links. That's it. That's the reason internet is so popular. It says that it's your responsibility. Whether you use a truck, you use bicycle, you use ship, you use aeroplane, you use whatever you want, scooter. It doesn't matter to IP. IP says that link is your responsibility. You transmit the way you want. And from there, my responsibility is tell you where to send, what is the next link. And then that link's responsibility is to send it to another end. Please try to visualize it and you will be able to understand. Okay. All right. Thank you.